My name is Martin. I'm with Robot 27 in Southern California. Today, I'm going to give you a demonstration on our lineup of dispensing products. We've got a Universal Robots UR3E and our syringe-based end effector for this demo. So as we get moving, there's a few things to keep in mind, especially about dispensing, just in general. The real big point is that there are literally hundreds of different options out there, from really simple pneumatic stationary type units to some ultra precise top of the line mechanically driven systems, and really everything in between. Robot 27's lineup of dispensing products, though, is really uniquely positioned in this market. Most of the pneumatic systems that are available for UR only offer a syringe-based model, but we also do have the ability to do cartridge dispensing out of two-part cartridges, and also single-part large construction adhesive type cartridges. So with the two-part system that we have, we're able to dispense in ratios of 1:1, 2:1, and 4:1. Those are great for epoxies and other two-part materials. We're also able to dispense, like I mentioned, out of these 300 milliliter or 10 US fluid ounce construction adhesive tubes. They do, adhesives and sealants, all kinds of stuff out of these. I'm sure you've used these before. So out of our single cartridge system, we also do have the ability to dispense from Semco or Semkit type cartridges, which is fairly rare in the pneumatic dispensing market. So between all three of those models that we have a really nice, flexible, low cost, and very redeployable solution. So these three products are really great for medium precision dispensing solutions. However, for higher precision projects, we also do offer this tip detection unit, which we'll talk about a little bit at the end of this demo. It uses a combination of laser and slot sensors to detect the precise location of the dispensing tip, especially when tips or cartridges are changed. Makes a big difference in the accuracy of the program. So anyway, like I mentioned before, these three models are going to cover a very wide variety of dispensing applications. Our engineers are more than happy to customize an end effector if you so need, and we're also very happy to run tests on your materials to make sure that the material that you're bringing to our solution is going to work well with our solution. That's certainly not a problem. So to get started, we're going to show you a little demonstration of what the system can do here. And we're not going to focus too much on the programming side of things today, but we are going to try and highlight the ease of use of the system. So let me switch over to the focused view here, and we'll get started with just a simple straight line bead. Just to kind of show you what we're looking for in terms of bead shape. Generally, we recommend that you start out with a simple straight line bead so that you have a chance to get your settings honed in. It's a lot easier to troubleshoot and to really hone in the settings on a simple path before you go program the rest of the complex motion, because every adhesive is a little bit different. So I guess the next logical point here would be, how exactly do we program this? So let me switch back over here and I'll show you a little screen grab that we have from Polyscope. So when you install our UR cap, what we're able to do here is drop this Robot 27 dispense node right into the robot program. So we have a few points that need to get set. The first of these is going to be that dispense start point. And that's the point at which material is going to begin leaving the end effector. So that's the point where you're positioned ready to start dispensing, and off you'll go. We also have the approach point, which is a safe spot above that dispensing starting point, just to make sure that we're not colliding with the part on the way in, we're not bumping into something on the way over to the dispense routine. Always good to have that little bit of security so that we're not causing damage to the part or the end effector or something like that. We also have the dispense ending point, so that's the point at which the material is going to stop leaving that end effector. And then we also do have the departing point, which is just like that approach point, that safe spot above the dispense endpoint to make sure that we're not colliding with something. So in order to get changed and work on a program that's a little bit more complicated, all we have to do is add a few more waypoints up here into this move P command. You can see that right above my screen there. Based on doing all of that, we can make a very complicated program from just a couple of waypoints to very complex routines with varied pressures and speeds and all of that stuff. So we'll go into a little bit more detail on how some of that works later. So in the default settings on the robot program, we are able to set a variety of kind of the default starting settings, if you will. So the first one of those is going to be the starting dwell. That's the period of time where the robot is at the dispense starting point, but we're just waiting for just a little period of time to make sure that before the robot starts moving, that it's pushing material out of the end effector. That helps, especially with more viscous materials, to help get the material moving before the robot starts moving, so we don't have things like a bead anomaly where the material might be a little thinner at the beginning than it is at the end. We also have the ability here to set the ending dwell. It's kind of the same thing on the other end. We want to make sure that the robot has a chance to pause when it reaches that ending point to let the material lay back down on the part properly before we move on. We can also turn on vacuum control or vacuum retraction, which is really handy, especially for syringe-based systems, to retract a little bit of the material that might be left in the tip back up into the syringe. What we find is that a lot of times with the runnier materials, when you use air pressure to push them out of the dispensing tip, we might have some drips that could fall down onto the part, but by applying just a little bit of vacuum pressure to that system, we're able to retract those drips into a safer location so that they don't drip down onto the workpiece. So this gives us a lot of extra flexibility. Being able to set these defaults saves you a lot of programming time, but again, those are just the defaults and those are system-wide. But we do have the ability to customize the dispensing pressure and also the starting dwell for each of these dispensing nodes. So we do have that strength, that flexibility to be able to do that. So now that we've kind of talked a little bit about the default settings, we're going to go into a little bit of a demonstration to show you really what this system is capable of doing. So I'm going to change back to the part camera here, and we'll get started with the next routine. This is going to be a zigzag shaped path. Each of the line segments in this zigzag is going to be at a different dispensing pressure. As it moves across the work part there, you'll see that the bead size is changing, and this is all controlled right from Polyscope, which is really, really excellent. So there's no need to adjust any hardware, no buttons or knobs that need to be adjusted. There's no changes to any valves or settings of any kind except for just typing that PSI value right into Polyscope. So that makes adjusting things really, really easy. The software that we've designed with the UR cap for this UR ecosystem takes care of all that for you. So again, this adds for a lot of extra flexibility, being able to not only set the parameters in the program to be able to vary the pressure during a dispense routine, it also helps cut down on setup type errors where maybe you're changing between runs of parts, and with a traditional dispensing system, you need to go adjust a regulator to change the dispensing pressure from one run to the next. Maybe they're different parts or different adhesives or whatever, but because those pressures are saved right inside the robot program, you don't have to worry about adjusting any of that. So that is a really big strength of this system as well. So once we kind of get the right combination of settings for the dispensing routines in combination with getting the robot moving at the right speed to lay down a nice bead and some other stuff, we're able to account for a lot of different types of abnormalities, like the bead shape, like we talked about earlier on, where the bead might be too thin or thick or not laid down just quite right. Also, adjusting things like the height of the dispensing tip, that makes a big difference, where if the dispensing tip is a little too low down in the glue path, it could be chopping the head off of the bead or dot or whatever the case might be. And again, being able to turn on or off for those thinner running materials coming out of the syringe-based units, having that little bit of vacuum retraction. So with our next demonstration, now that we've kind of showed you the way we can flex our muscles, for lack of a better term, with the system, I'm going to show you a little bit more of a practical demonstration here now that we have our settings honed in. So we'll switch back to the part cam here, and we're going to take a look at this on this double square that's off on the right-hand side of that part. Again, this is just a matter of programming a few waypoints in the system. So now that we have our settings really honed in and tight, making a more complicated program to dispense some material along this part path is just really simple. So UR, of course, makes this really simple. We're able to program this in 6 axes of control, so it really makes this system a quite formidable tool in the dispensing arsenal. So one of the things that happens, though, is that some people, they end up with parts that are more complicated in shape or geometry than they would like to have to program manually. So what we're able to do is, with the help of some offline programming, we're able to use a CAD model of the part and generate a path based on that model. So what we're able to do in this next demonstration here is we sent a model of this workpiece off to AutoCAD, and they generated some code for us, actually right in Fusion 360 with Autodesk, excuse me. And they were able to generate an offset path to dispense glue right along the edge of this part. So let me switch back to that part cam here, and we'll give that a look. So again, we were able to generate this dispensing path right along the edge of this complicated shape in this part. It's just set off of an offset off of that edge where the 45-degree surface there meets the normal surface. And that was it. So all we had to do was upload the code that Fusion 360 generated for us right into the robot, and that was it. Really, it's that simple. So that allows us to handle a lot more complicated routines, come up with stuff for complex curves or complex geometry. Really is a nice thing to have for us. So a couple of other things that we should talk about our dispensing lineup. One of the pieces that's kind of the unsung hero, if you will, of the lineup is what we call the air service unit. And it's not in frame here, but there is one connected to this work cell right here. And what the air service unit allows us to do is to, number one, check and make sure that your incoming air source has enough pressure to run the system properly. That's one of the big benefits to having the system. What we're able to do with the help of a digital pressure sensor is to check and make sure that those pressure requirements are met. And if they are, it sends a 24-volt signal to the robot. So what we can do is check that signal before we start the robot program to make sure that before we even try to dispense any adhesive or sealant or lubricant or whatever, that we have sufficient pressure to lay down that consistent bead or dot or path before we've even started. Really cuts down on problems where you might get part of the way through a part and the pressure has dissipated enough that you get an inconsistent bead. So that's a really great thing to add into your system. It also does have an air dryer that's attached to it, so you're making sure that you're getting that nice, clean, dry source of compressed air to power up the system. And then I also would like to talk a little bit about our tip detect unit. That's this unit over here next to me. Like we mentioned earlier on in the demonstration, this is really helpful for higher precision dispensing routines. One of the things that we run into from time to time is that when people change dispensing tips via the lure adapter that's in the end of this end effector or some other means, sometimes the tips, when they get changed, either get screwed in a little tighter than maybe the previous tip was attached. Maybe someone changes a cartridge or a syringe or whatever, and the end effector moves a little bit. What the tip detection unit is able to do is, before you start programming your robot program, to establish a baseline for the location of the tool center point, and then compare it every time that the program is ran to make sure that the tip is actually in the position that the program expects it to be in. So what we're able to do then is to teach the location of that tip into the robot's memory. And then if there's some sort of an anomaly, or maybe a bent tip or a tip that's screwed in a little differently, the program's able to compensate for those changes and then be able to dispense with a more consistent bead, because we've adjusted that TCP just a little bit to account for any abnormalities. So that makes the tip detector really great. We've had some people that use this outside of the dispensing sphere for really high precision machining, or really ultra fine detail pick and place applications. But we found that it's been a great tool for all of the dispensing routines.